For decades, consumers and industry alike have been waiting for a perfect battery, one that charges faster and lasts longer. However, it seems we have not yet reached peak battery in the search for the perfect battery, which is why people are still searching for it. But there has been a lot of attention on graphene since its discovery in 2004. Graphene is the latest wonder material in industrial circles. One application of graphene is in batteries or energy storage. Join us as we look into real graphene-enhanced batteries that just hit the market. The modern world has become so accustomed to batteries. Almost every electronic device runs on batteries. For example, TV, remotes, cell phones, flashlights, toys, or even our vehicles are powered by batteries. A battery's chemical reactions involve the flow of electrons from one material to another via an external circuit. The two electrical terminals called electrodes are separated by a chemical substance called an electrolyte. This electrolyte helps in the flow of electrons between terminals. When this battery is connected to an external circuit, the electrolytes move as ions, allowing the chemical reactions to be completed at the terminals and thereby delivering energy to the external circuit. This movement allows current to flow out of the battery. Another form of energy storage, called ultracapacitors or supercapacitors, are a monumental breakthrough in capacitor technology. Ultracapacitors or supercapacitors are an energy storage technology that offers high power density, almost instant charging and discharging, and lifetimes of more than 1 million charge-discharge cycles. Ultracapacitors are bigger capacitors that are inherently better energy storage devices that are able to store a larger amount of electrical charge than chemical batteries. Ultracapacitors can be used wherever a large amount of power is required for a short period of time. Unlike standard capacitors, ultracapacitors have an electrolyte between the plates rather than a dielectric, meaning they store energy in an electric field rather than in a chemical reaction. Unlike batteries, they are resilient to high temperatures and change much faster than batteries. Supercapacitors are rapidly becoming another area where graphene can put its abilities to use. The graphene material can improve the performance of traditional batteries, such as lithium-ion batteries, by increasing the battery's conductivity and allowing for faster charge and discharge cycles. Because of its unique combination, graphene has emerged as one of the most promising nanomaterials. Graphene is not only the thinnest, but also one of the most robust materials. It conducts heat better than all other materials. Graphene is an excellent conductor of electricity. It is optically transparent, yet so dense that it is impermeable to gases. Not even helium, the smallest gas atom, can pass through it. Graphene is a single, flat layer of carbon atoms packed tightly into a two-dimensional honeycomb arrangement. This sheet is only 1 atom thick. Monolayers of graphene stacked on top of each other form graphite. Since a typical carbon atom has a diameter of about 0.33 nanometers, there are about 3 million layers of graphene in a 1 millimeter thick sheet of graphite. Harder than diamond, yet more elastic than rubber, tougher than steel yet lighter than aluminum. Graphene is the strongest known material, which possesses other amazing characteristics. Graphene is a next-generation supermaterial with extraordinary properties and forms the basis of many derivative products and materials. One of the derived materials is curved graphene. This is where Skeleton Technologies comes in. The German-based Skeleton Technologies has been at the forefront of graphene-based supercapacitor development for many years. The company recently made some major announcements, including a large financing round worth more than 70 million euros, the Super Battery Project, and several strategic customers and projects, including ones with Medcom, Skoda, CF, Wrightbus, and Marubeni. Skeleton is targeting 4 main markets: the automotive one, cars, transportation or trains, trams, buses, industrial systems such as oil and gas systems, construction, medical and more, and the power grid. It sees good demand and growth in sales across all of its markets. Skeleton's main technology is its curved graphene, which is a type of graphene, but not a standard one. The curved graphene retains the properties of graphene high conductivity and large surface area, but can be inserted into electrodes much more easily compared to other graphene types. This enables Skeleton to achieve high performance in its supercapacitors. Skeleton produces graphene-enhanced supercapacitors. Based on its curved graphene technology, the company claims its capacitors are the best performing capacitors in the world, with the highest density and by a large margin over its competition. The enhanced performance is behind Skeleton's extremely fast growth in the last few years as the company supplies its solutions to a wide range of applications. The company reports a backlog of over $200 million in products that it will supply in the next years to support its fast growth. Skeleton is developing new production technologies and scaling up capacity. With support from the German government, Skeleton has tripled its revenues for 3 years in a row up to 2020, and in 2023 it hopes to continue its fast growth. Due to the unique storage capability of supercapacitors, it has been widely used in various applications. The two popular applications of supercapacitors today are wind pitch control and grid energy storage solutions. Wind pitch control systems are traditionally powered by lead-acid batteries, but newer turbines are adopting supercapacitors that outperform the old solutions. Skeleton supply its capacitors to many such turbines in this market and will likely continue to grow in the future. Another important application for Skeleton's supercapacitors lies in the grid. Large power banks up to 100 megawatts are used to regulate the grid. These installations need to release their power quickly, which is where Skeleton's supercapacitors come into play. Skeleton's Skullcap ultracapacitor series is unique in the world of ultracapacitors. These capacitors are protected by 11 patent families, covering everything from the raw material to the synthesis and production processes. The cells provide up to 4 times higher power density compared to the competition, as well as lower ESR, leading to a much better application lifetime. Another advantage of this is that cooling systems can be downsized or removed altogether. Skeleton also touts the reliability along the life of the Skullcap battery. The special purification and post-treatment procedures applied to the materials used in Skullcap ultracapacitors results in industry-leading lifetimes of 15 or more years in many applications. This is because ultracapacitors store energy in an electric field rather than in a chemical reaction like many other batteries. However, Skeleton says batteries and ultracapacitors are complementary technologies. That is, batteries provide energy for the long term, while ultracapacitors provide fast reaction and high power. A good example is KERS, or kinetic energy recovery systems, where braking energy is stored and reused for acceleration or lighting. Another great use case is power quality. Even a tiny disturbance of a few microseconds in power quality can lead to tens of millions in damages. Without ultracapacitors to protect the equipment infrastructure and grid with immediate response. Skeleton has an ISO 9001 certified production facility in Gross-Rohrsdorf, Germany, the most modern ultracapacitor factory globally and the largest of its kind in Europe. What do you think about the new graphene battery and Skeleton Technologies curved graphene? Let's hear it in the comment section below.